A doctor's prescription calls for the creation of pills that contain 12 units of vitamin B12 and 12 units of vitamin E. The pharmacy stocks two powders that can be used to make these pills. The first powder contains 20% of vitamin B and 30% of vitamin E, and the second contains 40% of vitamin B and 20% vitamin E. How many units of each powder should be mixed in each pill? So we want to begin with a variable key, and we need to analyze what the unknowns are in the problem. What are we looking to find? And so this last sentence tells us we're looking to find how many units of each powder. And there's two different powders that we're going to be mixing together. And we don't have a name for the powder in the problem. Be careful because we're not looking at how much vitamin B and how much vitamin E we're mixing, but rather the one powder contains both vitamin B and vitamin E. So X is going to be the number of units of the first powder. I'm just going to call it powder 1. X equals the number of units of powder 1. And then we have a second powder, so Y can equal the number of units of powder 2. So we have our unknowns, and we're looking to set up two equations so that we have a system of equations. So for mixture problems, I kind of like to have a diagram so I can visualize kind of what's happening, and I use canisters to help me visualize. So I've got this first canister, and this is my canister that's containing the first powder, so I'll put a 1 up here. And then I'm going to be adding it to another canister. So I'm going to be adding some of powder 1, and we're going to be adding it to powder 2 to make my ultimate goal. So my goal, if you read the problem here, my goal, it says, is that we want to create a pill that contains 12 units of vitamin B and 12 units of vitamin E. So when I take my two powders and I'm going to mix them together to make these pills, and the pills here, my pills that I'm creating need to contain 12 units of vitamin B, B12, and 12 units of vitamin E. So that's my goal. So let's see, what do we know about powder 1? So we need to reread the problem. And you'll see that it says that the first powder contains, right here, the first powder contains 20% vitamin B and 30% vitamin E. So I'm going to draw that in my little canister. I know that 20% of this powder is vitamin B12. So I'll put 20% B. And then I also know that 30% of the canister is vitamin E. Clearly not drawn to scale. But that means that 50% is unknown. So 50% of this canister, I'm not sure what it is, but I know 30% is vitamin E and 20% is vitamin B. And then the second powder is 40% vitamin B and 20% vitamin E. So I'll mark that. I have 40% of this canister, that's vitamin B, and then 20% here, that's vitamin E. And then we want to mark how much do we actually have inside the canister total. How many units do we have of powder 1? And that's our unknown. X is the number of units. So I'll put X on top. This represents how much I have sitting in the canister total. I have X units of powder 1, and I have Y units of powder 2. So now we're ready to set up our system of equations. So we're going to start with how much vitamin B12 I want. So I could even mark my first equation as a vitamin B12 equation. And I want in the end to have 12 units of vitamin B12. So now we just need to figure out how much vitamin B we have in each of my canisters. So for the first powder, I have X units in this canister, but it is 20% vitamin B. So 20% of X would be 0.20 times X. My second canister, I have Y units of powder 2, and it is 40% vitamin B. So that would be 0.40 Y, and that's equal to 12. How much vitamin B I want in the end. And now we go to vitamin E. So same idea, I would like to have 12 units of vitamin E, so I could mark this as my vitamin E equation. I have X units of powder 1, but it's 30% vitamin E, so that would be 0.3X or 0.30X, plus my second powder, I have Y units, and it's 20% vitamin E. And now we set up our system of equations. I've got two equations with two unknowns. Now, methods of solving would be substitution or elimination. And for this problem, since my variables, you can see the terms with the x's are stacked on top of one another, same with the y's, and over here I have the constants stacked. This is my signal that tells me that elimination would be a nice method. So we'll go ahead and solve this with elimination. Now before I go forward with elimination, let me mention that if you're a person that really dislikes all of these coefficients that are decimals, and you'd rather not deal with the decimals, you certainly could eliminate the decimals. So you could eliminate the decimals just by multiplying all of the top equation and the bottom equation. In this case, since the decimals are all 0.2, 0.4, 0.3, and 0.2, we could just multiply all of our equations by 10, and that would basically move the decimal one place to the right. So let me just mention, I'll put OR here. If you want to eliminate those decimals, multiplying the top equation by 10, moving your decimal one place to the right, that would give us 2x plus 4y, and then of course 12 times 10 would be 120, and then 3x plus 2y equals 120. So if you're fearful of decimals and you prefer to wipe out those decimals, you certainly can eliminate them just by multiplying by 10. I'm going to go ahead and just keep my decimals because that seems like an unnecessary step to me. So I'm just going to work with the decimals, and I want to eliminate a variable. So on this problem, it seems most logical to eliminate y, because then I would only have to multiply the bottom equation in order to eliminate the terms that have y. So since the top term here is 0.4y, then I want my bottom term here to be negative 0.4y, so I need to multiply by negative 2. So I'm going to multiply the right hand and the left hand side of my equation by negative 2. So my new equation, when I multiply by negative 2, is going to be negative 0.6x minus 0.4y is equal to negative 24. And then my top equation, I'll just copy it again, stays the same. So instead of 0.20, I'm just going to write 0.2x plus 0.4y equals 12. And now I'm ready to go ahead and add the two equations together. And notice when we do add the equations together, we successfully will eliminate the y terms. So adding negative 0.6x plus 0.2x is going to be a negative 0.4x, and that'll be equal to negative 12. And then we'll go ahead and just divide by 0.4, and that will give us x is equal to 30. So in the end, two steps always: make sure that you answered the question and make sure that you have the right units. So going back to our original problem as well as our variable key, remember that the original problem, my question was right here: how many units of each powder do we need? So we need to know both how many units of powder 1 and how many units of powder 2. And x here, my variable, x was the number of units of powder 1. So back to my work. X is going to be 30, so that would be 30 units are needed of powder 1. But now we also need to know how many units we need of powder 2. So once again, going back to our system of equations, we have two equations here that we started with. We have the 0.2x plus 0.4y equals 12, and we also have the one below it. It doesn't matter which one you substitute back into. I'll go ahead and just choose the first one. So that would be 0.2 times x, but now we know that x is 30, plus 0.4, y is equal to 12. And now we need to just solve this equation. So 6, oops, try that again, just plain 6. 6 plus 0.4y equals 12. So 0.4y, when we subtract 6, 0.4y will equal 6. And then finally divide. 6 divided by 0.4 gives us that y is equal to 15. So therefore I also need 15 units of powder 2. And that's how much I would mix together of each of the powders to get the desired amount of vitamin B and vitamin E.